see what happened. Oh shit! I wish I had a z-score chart. Too bad. So a very smart thing to do in almost any math class, especially ones where you have a lot of words involved, is to do this for yourself. So I'm not always going to do this for you, but if I were you, I would just find those things in the write-up, right? So what is the x bar in this problem? 92.6. The standard deviation was, and how do I know it's sigma? Not just because I wrote it, how do I know it's sigma and not S? Because it says it's a population. Okay, good. I like that. So that's 4.11, and then N is 37. Cool. So N is always the size of your sample, period. So that might be the first thing you want to look at because it's always the same. It's always the size of the sample, so you can find that pretty quickly. The z-score we talked about already quite a bit. So middle 95%. That means there's 2.5% down there if you looked it up. The plus or minus is built in, so when you find the z-score, you don't care if you find the negative z-score or the plus or minus is built in. So you'll get negative 1.96, but you just care about the actual number, 1.96. Okay, maybe. So then it's just plug and chug, right? So you put 92.6, give or take, 1.96 of these. And I highly recommend you do this, but you can do 92.6 minus blah blah blah, 92.6 blah 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 if you want to. Right? So did anybody get the error? Anybody got the error? 1.32? Okay. Thank you. Oh, it's loud in here. And now I just have to add that, subtract it, right? So now my interval will go from 91.28 up to 93.92. Thank you. So that's acceptable just to identify your interval, but then you always have to give me this, right? Because I'm a jerk. That's why. So we are 95% confident that the interval, yeah, you're good. The interval 91.28 inches to 93.92 inches contains, I'm going to often say the true, and when I say true, I mean population, right? So the population, if I'm not thinking about it, I'm just going to say the true, contains the population mean what? Length of dolphins.
Did you say dolphins or all dolphins? Oh.
Yeah. Is that all right? So it basically always sounds the same. We are such and so confident that our interval contains the real mean. Pretty soon we're going to learn percentage. Are we all right? Okay. Part B, which some of you guys did the work on part A, which is understandable because finding this z-score is a little weird because the area you work with is not the area the chart understands, so you got to be careful. What z-score did you guys get for part B? Because it's the only real difference.
1.645.
Yeah. All the information's the same. It's the same problem, right? I hate projectors. You're fine, but I just hate all of you. So what do you get for the error this time?
90.3.
No, what do you get for the error? 1.111? Neither. Okay. So then your confidence interval is 91.489 up to 93.711. Okay. So we are 90% confident that the interval 91.489 inches to 93.711 inches contains true mean length dolphins. Yeah. All right. You can approximate English. Yes.
Well, we get marked down if we put it like we said, in the interval of 93.711 and 91.489. Like if we swap the numbers instead.
Yes. No, I don't know. It depends on how I'm feeling. You would never say, okay, what age range can do this? Oh, anyone from 20 to 11. I mean, no, 11 to 20, correct? So it's always from lower to higher. And I always get people, how many intervals are in here? How many intervals do you see? One, yes? An interval has a from, to. So that's why I say the interval. There's not two intervals. There's one, from, to. One interval. Okay. I know. It's picky. I don't care. Statistics is the merger of English and math, which is always exciting. Yes?
For one of the intervals, I put 91.49.
You're fine.
That's fine.
Yeah, I just did more for whatever reason. It has to have at least as many decimals as this, so I actually went way further than I had to, but does it make sense? Just like standard deviation, say at least 3, so you can go to 5 and be fine, right? Okay. Everybody with me? Okay, you're all like, physically, we're in the same room. Okay. Part C, I always get somebody to do this, which is why I try to make a big deal out of this. I already know, and by the way, real quick, you guys see how I go back to 95% confidence? Right? So I'm back up, I'm talking about this. I already know that if I have a sample of 37, that gives me an error of 1.32. You with me? I already know we did that, right? A sample of 37 led to an error of 1.32. Is everybody cool with that? I love you guys. You're all like, give them nothing. Okay. I'll somehow. So if I put a 1.32 into this equation, of course I'm going to get 37 out. So don't do that. How much error do I want? What do I want the error to be now on this one?
0.5.
I want it to be half an inch, right? I want it to be half an inch off, not 1.32 inches off. I already know what sample size leads to this. So now, and again, it's still the same exact problem. In part C of number 1, all the stuff is the same. 95% was 1.96. Standard deviation was 4.11. The error I want is now 0.5. I don't know why I squared each piece. I actually like it better like this, but you could do either way, right? Algebra doesn't care. And you're like, I know algebra doesn't care, but you could square each piece, you could square the whole thing. I'd rather square the whole damn thing. A64, 128, I don't know. Does that sound about right? No. 64. Actually, going to be twice as much, 256, or like 260, or what is it? 259.57,
5.7.
and you always round it up so you don't have to chop any dolphins. Don't be doing that. Poor little dolphins might be smarter than us. Huh? Oh, are they? I don't know. The jury's still out. There's a chance they are. Most likely not quite, but there's a chance they're smarter than us, and they're like whenever we think we're experimenting on them, they're experimenting on us. Who knows? I did not just say dolphins are experimenting on us. I love it. Just in case you guys go, guess what my teacher said today. All right. You guys all okay? Does it make sense that I needed, when I had 37, it was this big of an error, so if I want to make the error much smaller, I need a much larger sample size. Does that make sense?
Yeah.
The bigger the sample, the less error they should be in what I get. We knew that. You guys knew that on day 1. You knew a bigger sample was better. Obviously, behind this entire discussion, the sample needs to be random, correct? I don't care how big your convenience sample gets, it sucks. You with me? As long as it's a random sample, bigger is better. Okay, but smaller is not, doesn't mean, terrible things. One last thing I think for today, and then we'll get out a little bit early. Is that all right? You guys will be upset. Is everybody okay with this worksheet here? I mean, again, as we see very often happens, the nuts and bolts of the problem is not as difficult as the understanding the concept, and that only should make sense. The concepts are always the hardest things to get, right? The nuts and bolts are normally not that bad. So one last idea for today. And actually, yeah, I should have been looking that up. Darn it. Oh well, Jeff. Things happen. Thank you. Sleep. Okay. So, I'm going to develop the formula for a confidence interval of a population percentage. And you've seen this stuff before, even if you didn't want to. Is there anybody in here who pays any attention to election stuff, politics stuff? Do you get that information even when you don't want it? Does it somehow find its way in front of you?
Yeah.
Have you ever seen stuff like, looks like 44% are going to vote for this guy,
Yeah.
this old white guy, and 48% going to vote for this other white guy? So, but at the bottom of the screen, if you ever notice, whenever you see that in a newspaper, do you guys know newspapers exist? I don't use a newspaper, but at the bottom of an article or something, they will often say plus or minus 4% or something like that. Okay, so you could see an interval. For example, they could say 44% are going to vote for Jimbo, and 48% are going to vote for. Sorry. I'm just going to put Ron. Sure. So at the bottom, you'll see something like, if I saw plus or minus 4%, what does that mean? What's the actual interval for Jimbo then? Go, Jimbo.
4 to 4.8.
It would be down 4%, up 4%, correct?
48 or 40.
Is that cool? 40 to 48%. What about for Ron?
Be 52 to
44 to 52, correct? Could Jimbo actually be ahead?
Yes.
Hell yeah, Jimbo could be there and Ron could be there. Yes?
Yeah.
So this is a huge thing when you see these polls. You have to realize there's an inherent error in them. Not because they did something wrong, but because it came from a sample, and a sample will inherently be different from the population. You're always going to have to cover your ass with this. Now, did they go, oh, how sure are we? Plus or minus 4, okay. The next day, 5, let's make it 5. No, this number is going to come out of the math. Right? Exactly the same place we just saw from, plus or minus blah, but now I'm going to have percentage shit in there. So, I'm going to go back to, I just had a flashback. One of my teachers would always say, go back to fundamentals, go back to fundamentals. I'm going to go back to where we started for the other confidence interval formula we made, which was here. You can do it, Jeff. Write it down. There it is. Okay. And what I'm going to do, so this, what we did before was we replaced this with X bar and so forth, right?
Yeah.
So what I want to do, I'm going to replace this with percentage stuff. So if I have P and Q and N, what's the mean? NP, yes? Remember that? And what's the standard deviation? Square root of NPQ, yes? Yes, yes. Okay, I like it. Okay. So, this is, I think I have to go over here. So if I put NP, give or take Z, square root of NPQ. All right. So there's one problem in this formula, the way it's written. Does anyone know what P specifically represents?
Probability of positive
The probability of success.
success.
And success doesn't have to be happy. Just whatever we're looking for. Here's the big thing though. If you look at every single problem we've ever done, any binomial problem we've ever done, the percentage I gave you was always of a population. Every damn time. Okay, you with me? If you look back, every damn time we ever did it, it was from an entire population. Okay, so I am not going to have that, am I? I'm not going to know the percentage of everybody who wants to vote for Jimbo, right? So what's the symbol for population mean? Mu. What's the symbol for sample mean? X bar. So what's the symbol for population percentage? P. What's the symbol for, you're going to love this. Oh, you're going to love this so much. Sorry. The symbol for sample percentage, something you never want to wear, it's called P hat. I don't know what you guys think of me, but maybe you think I made that shit up. That is the official symbol for a percentage from a sample. Just like X, you put a bar on it, and suddenly you guys are all like, sure, sample mean sounds good. But now I have a problem when I put a little on top of the P. It's just a symbol, right? I have no idea what was happening that day when the math people said, yeah, let's put a little hat on it. Right? You guys kind of with me. If I know P hat, how do you think I find Q hat? Subtract from what? 1. So I don't care what clothes they're wearing, P and Q have to add to be 1, right? Thankfully, this is the last type. We don't have, they're not going to wear other clothes. We don't have P shorts or anything. Okay, we have P hat. So then I could find 1 minus P hat will give me Q hat. So this is currently a population. We're not going to have the population. We're just going to have a sample. Let me take this over here. It's got to stay up so everybody can see what's going on. So if I rewrite what I've got, but I'm going to put sample stuff in now. Okay. So for example, if I said, oh yeah, I went and talked to 80 people, and 40 of them said they're going to vote for Jimbo. Let's look at it. We need President Jimbo. Basically there. 40, what would the sample percentage be? What percentage did I see in my sample they're going to vote for Jimbo? I talked to 80 people, and 40 of them said they're going to vote for Jimbo. What's the sample percentage? 50%. 40 out of 80, correct? How do I know that's a P hat? Because it came from a sample I took. Okay, maybe. Every binomial problem I've given you, I said 11% of all Americans are left-handed. 17.6% of all these people found a job. Whatever, right? It's always been of a population because it was just, we didn't know about P hat yet. We didn't need to know about it yet. Yeah, maybe. Now, doesn't this, remember how it was supposed to, how do I build this in now? Catch the mean, and isn't the mean NP? So I'm going to, this confidence interval is supposed to try to capture the real mean, which is n times p. Are you with me? It's not the population. It's not the sample mean. It's the population mean because it's got a p without a hat. Go with me. We're almost there. Last step. We'll do examples of this next time. If I want to be able to say 40% give or take 4%. So don't I want a pure percentage here?
Yeah.
So I want to get rid of the stupid n, right? Stupid n. So let's just divide by n. So this part's easy. I can catch the percentage with this. Now what can I do over here? Can I kill those n's? Can I just kill those n's? Is somebody over there going, yeah. Can I kill those n's? Why not? How many n's are on the top?
1,
No. See who gets this.
3.
How many n's are on the top? Half of an n. You guys see that? Isn't that half of an n up top? What does this symbol mean? Does this mean 9?
No.
How much of a 9 does that mean?
Square root.
Half of a 9. What's half of a 9 multiplicatively? 3. Yes? Which explains why square root of 9 is also 9 to the 1/2 power. It's half a freaking 9 multiplicatively. Side lesson, sorry. Coming back. I can't cancel these because they don't have the same root. They're not equal to each other. Square root of n, does that equal n?
Oh.
You know the square root of n does not equal n, so how can you cancel them unless they're the exact same? So help me out. They have to have the same root, correct?
Yeah.
The square root of what is n? See if you guys are cool with this. N squared. So can't I just replace this with the square root of n squared?
Yeah.
Now I can kill them because they both have the same root. How many n's cancel? How many n's cancel? 1. How many n's are left? 1 n cancels. How many are left?
1.
Where? On the bottom. That's trying to be a Q over there, by the way. Oh, that looks great, Jeff. That looks great. Thanks a lot, Jeff. So now we're going to get a problem like this. We talked to 80 people. 40 of them want to vote for Jimbo, right? Create the 90% confidence interval for the true percentage you want to vote for Jimbo. We would put 0.5 plus or minus z, square root of 0.5, 0.5. Right, so z would be what I say, 95. We look at the z score just like before, right? Different formula, built off of the same idea. So don't freak out yet. There's an example problem on the other side, but we'll do that next time, I think. I'll give us all a little bit of an early exit.
I found it. You gave it back to me last time.
Oh, thank the gods. Oh, that means I need to